And welcome to today's free webinar series, Maximizing Data Quality for Value and ROI. Subject, Emerging Trends in Data Management. My name is Matthew. I'm Senior Director of Sales here at TechXtend. I want to run you through a brief agenda as to what will take place today. Brief intro on TechXtend, followed by today's webinar, Emerging Trends in Data Management, hosted by Victor Rodriguez, our data management and data warehousing consultant here at TechXtend. Followed by your questions and a summary. Formerly Programmer's Paradise has a 30-year history as the source for developer and database tools. Our focus now encompasses virtualization and cloud computing, storage and management, business intelligence and information management, and device management, while focusing on our core business of software, developer, and database tools. Our credentials, including the leading e-seller of developer and infrastructure tools under our base worldview ecosystem. We are an CA partner and the #1 data modeling reseller for CA in North America. We have CA sales and engineering team in-house focused on database modeling and infrastructure design and training services. Base worldview, we include industry-leading database tools for your end-to-end database infrastructure needs. Now turn things over to Victor for today's webinar. Victor?
Thanks everybody for attending. Today's talk is going to be a little different than what we've done in the past. I'm actually going to be talking more about the just the emerging trends in data management in the current world data management, rather than talking specifically about Irwin and looking at exercises within the product itself. So for today, we talk about the realities, this kind of the challenges we're encountering in this 21st century that we live in now, these kind of new technology that's emerging, the reality of the market that we're living in, and how that is leading to new challenges that we need to address, and then the emerging strategies and technologies that are out there that can actually assist us in this place. Some of this, we want to kind of cover some topics that you may be hearing buzz about, but there's a lot of questions as to what a lot of this stuff actually means. We'll talk about the role of the data modeling and traditional data modeling and architecture teams in that emerging landscape. And then we'll have a session at the end, so please feel free to put questions during the presentation, and we'll address them towards the end, or save your questions to the end, and we'll try to leave some time there at the end to address them. Talking about here, big, right? So that's a little pun there, but actually that's kind of like a big buzz term now. Big data. What does it mean? What is this this concept of big data? We hear it buzzed about. Even in mainstream media, it's kind of crossed over as a topic of conversation. And what does this really mean as far as the addition of data? Really, what we're talking about here, it's kind of the term was kind of so loosely defined, and now it's kind of there's some consensus coming to what this actually means. And we're talking about 3 V's. The 4th V that sometimes people talk about veracity or data quality, but really when we're talking about data, big data, I should say, we're looking at these 3 V's. So it's the volume of data, the variety, and the velocity of that data. And this is kind of coming to fore in this current, this current time for realities of this century that we live in. So first of all, we live in a real-time world, right? So our customers actually demand, to have mobile devices. They're connected 24 hours a day. They want an interactive experience with their friends, with their family members, and with the companies they do business with. And it's a global marketplace as well, right? So we are actually seeing where the Chinese have now emerged as the second largest vendor or second largest customer for U.S. products, for example. And of course, we are outsourcing a lot of our technology and other labor out to other parts of the world. So we live in a global world. We have global teams internally at our companies, and our customers are global. We need to have one. Our corporations need to have one face to represent the global market. challenges, the realities of the world. Speaking of mobile devices, I mean, for me, the engine of all of this is the popularity of mobile devices. It's pretty amazing that I remember the first time I presented similar material to this at a conference, that my statistics were that by the end of 2010, there were over 4 billion mobile devices in the world, and that 17% of them worldwide were smartphones. And now we actually just updated these statistics as this summer, and the statistics that came out in June are there are now 6 billion mobile phones in the world. 30% of those are smartphones. In the United States of America, we are now at 50% smartphone adoption. So you can see how in just a very short period of time, just in 2 or 3 years, you can probably state from your personal experience that you are banking on your mobile devices. You are accessing the internet primarily on your mobile devices. You're probably accessing Facebook primarily on your mobile devices, checking into geographically specific services and locations based on those devices. So see how even from your personal point of view, how your interaction with locations, with businesses, with each other is fundamentally changing. And that's to the point of this second major point, is that we're, this reality of this new climate is that we're not only in a mobile world, but it's being run by digital natives. So I'm sure most of you are probably older, like I am myself, and you're probably, have already adapted to many of these new technologies. You've kind of just integrated it seamlessly into your day-to-day process, as far as reading your emails, as far as interacting with the locations and businesses and friends that you have. But imagine what your children are experiencing now. My nephews knew how to access games on mobile devices before they even knew how to speak. So it's you see how that is fundamentally changing in this world we live in. And this is, of course, the next generation of consumers. They're the ones who are going to be driving business requirements in the future, and their expectation, of course, is that you are a mobile enabled 24/7 business that has gives them a good social experience, that they can personalize to their own demands, and they can actually interact with their friends via your platform as well. And speaking of platforms, there's another key change in the way that we have to think of the challenges of marketing to these users. In the old days, we basically developed to have applications that would run primarily on a Windows environment, but definitely on some kind of personal computer. And now we're in a post-PC era where you're basically interacting with your users and with your businesses and with your partners via the cloud, for lack of a better term, via some kind of web-enabled platform that's been designed. That could be, for example, that we build platforms on platforms. So, perfect example of that is how Facebook is a platform that you can consider is running on mobile devices, since most people are actually accessing Facebook via mobile devices. But then Facebook becomes its own platform in which developers can build their storefronts, and they can build their games, and they can now, within that, create yet another platform. So you can imagine the iPhone is a platform, and within the iPhone we everybody probably has Angry Birds installed. I think they have 500 million users at this point. But if you've been playing Angry Birds recently, you're seeing that you're getting 30-second TV commercials being pushed onto the game. So now the platform has become a platform for the game, and the game has become a platform yet again. So we're seeing that this flexibility and this stacking of platform within platform is going to be another trend in the future. So all of these things, imagine that every single one of these things that I'm describing, whether it's the amount of check-ins you have, whether it's the amount of mobile devices that are being sold every single day, whether it's the number of connections that there exists between multiple platforms within a particular piece of hardware, that all of these things lead to a huge a tidal wave of data. You see that this is just exponentially growing. Challenges that, of course, the largest companies of the world are already dealing with, but these are things that impact all of us day to day, and even as small to medium businesses, there are things that we do need to strategize about, because if it's not something that's a current concern, it's something that will definitely be a concern in the near future. At that point, I have an example here of this evolution of what the information management has been in just a relatively short period of time. The younger out there, if there's any 20-somethings out there, you probably don't even realize that there are tellers inside those banks out there. But in the old days, we had to actually go and hand money to a teller inside of a building. As crazy as that may sound. You had a situation where you had dozens of touch points potentially. If you had like a local bank, it was a handful of branches, and those had tellers within them, and that was the touch point for your consumer. And that consumer had, created certain transactions, and all those transactions were backloaded into probably some mainframe somewhere that would, kind of collect that customer information, those transactions within this relatively slow window of batch processes. Now, also as another point of this is your customer's experience was really defined by whatever your teller simply recorded. Did the teller basically say he had a good experience, had a bad experience? If you want to kind of get the sentiment from your end user, you kind of had to guess as to, was my sales going up, going down, and what kind of general experience did your tellers or your employees kind of tell you your customers were experiencing. So it was a much slower business cycle. Of course, the advent of the ATM in the 80s and around there, and obviously then we started seeing where primarily the banks became the source for the ATM machines. And as a matter of fact, any of you who live in a large city, in New York City, of course, you'll have hundreds of Chase branches, and primarily they'll just have an ATM inside of them, and they're basically on every single corner. There's occasionally a teller you run into here and there, but for the most part, unless you go to one of the main branches, you're looking at an ATM machine. And of course, it was a fundamental change in the way your users were interacting with your business. You now have thousands of touch points. Very easy to roll out an ATM machine in different locations. Users had dozens of different transactions they could potentially be encountering with each one of those machines. Had basically become an automated teller. And of course, the actual speed of those transactions could be, you had kind of some leeway. That transaction could process in a day, in a few hours. But usually, if the transaction took a few hours to transact or for the updates to occur internally in the system, most users were not. There wasn't an expectation from the consumer of that speed of transaction. Now we arrive at the mobile era, and now we have millions of touch points. Users are primarily beginning to, or I should say, a subset of the users are primarily beginning to probably interact with their bank accounts via mobile devices. We're going to see a huge evolution. In the case, this really hasn't been adapted that widely yet, but you see in certain areas of the world, Africa, in parts of Asia, South Korea specifically, where basically even mobile payments have outstripped credit card swipes. So you're seeing how this is fundamentally, Newsweek recently had an article about the end of money, and that's really what they're talking about, where, if this happens to take off in the U.S., this idea of the mobile wallet, and all the big resellers out there are, or I should say all the big vendors out there are investing heavily in this concept of a mobile wallet. And if that does take off, we're really seeing a fundamental shift in the way users actually pay for things. And of course, that's going to fundamentally change the user's relationship with the bank. But in those terms, we're looking for real-time transactions. You've probably already seen this at your many shops already accept mobile payments, and you can basically just wave your phone over the swipe machine, and your transaction will take place. But of course, that's something that to build up that confidence with the end user, it has to be instantaneous, it has to be reliable, it has to be secure. So these are, the expectation is a real-time transaction. And if that's the case, of course, it'll be evolutionary for businesses out there, but it's something that is obviously a concern for everybody. Of course, and lastly, is that these are also not only real-time transactions, but an expectation from the end users that you're going to have context and geography-specific offers. So that's another really key feature. Banks are now offering loans to users who need college loans. They're giving you, refinance or college funds for babies when they know that you're potentially having a child because maybe you've done some purchases at Toys R Us or Kids R Us, I should say. See things, identifying these patterns, you need to have context-specific offers and, of course, geography-specific offers. This explosion of, Google local and also Facebook's local services and, check-in services and Groupon and all these other features. These are becoming multi-billion-dollar companies, even the smallest ones that I've mentioned, because of the ability of basically making an offer that's contextually important to the user, something that's going to get a much better hit rate than just an mailed flyer or an email that ends up in the junk drawer somewhere, and of course geographically specific too if you are brick and mortar type location. Inception before we dig even deeper into some of the technology, misconceptions about big data. So big data means big volume. So of course, volume is definitely one of the three V's, like I mentioned before, that the reality is that the strategies around big data actually are going to matter to everybody, even to small to medium businesses. And a lot of this is being enabled via another big emergence in recent times, which is these managed service providers. So these service providers are really allowing many small businesses to kind of come together to create an economy of scale where you can actually kind of take advantage of some of this technology without necessarily having to be a very high volume data center. These, of course, is the velocity. So how quickly do your users need to have their data updated, whether this is some kind of transaction, like I was mentioned before, some kind of mobile payment, or whether it's something that needs to be context specific. For example, someone checks into a hotel and their favorite store has a coupon and it's 2 miles away, and of course they might be on vacation. They have no idea the store is there. That coupon could be very valuable to them if they need to go shopping. Even at small size, small scale, the validity of that data has value, as well as the other feature I mentioned before as well. Another misconception, big data is always unstructured. So that's actually another big point. Everybody kind of, anyone who does think about big data on a regular basis, probably is thinking about Facebook posts. They're thinking about tweets via Twitter. They're thinking about this type of completely unstructured data. And the reality is that a lot of data that is considered completely unstructured is really not always structured, and even unstructured data has structure within it. But the reality is we're looking at not necessarily the unstructured data, but just the variety of semi-structured data. So that's a key differentiator. Traditionally, when we look at databases and maintaining databases, we're looking at data that's really formatted to go in tables, and we kind of have a very clear understanding of the application that will collect the data and how it's going to look when it lands inside the table. What's my identification number, my social security number, my phone number, my cell number, etc. I've kind of a decision as to what data I'm going to collect, and there's an expectation as to how it's going to be formatted when I receive it. So don't think that necessarily data is always structured. Think of it that it has a variety of structure, and we don't always necessarily know how to handle it. So some of this semi-structured data that has a lot of value and is going to have even more value as time goes forward, you can imagine that your video files contain a great amount of important data that you need. And we have to have a strategy. For example, if you do aggregate a lot of video, you need a strategy for identifying tags and tagging that data accordingly. Data that has a format, it's a data that can be stored, formatted and stored as in some kind of structured format, but still has a lot of the challenges that the unstructured data happens to have. Audio files are similar. Emails, of course, have a lot of metadata that's very valuable. Even though the body of the email probably has to be stored in some unstructured way, the email itself has a 2-field, a 4-field. Of course, we can do some analytics of the strings within the emails themselves and do additional identification of structured information as well, phone numbers, etc. So there is structure within unstructured data. Tweets are another really good example. Tweets, unlike Facebook posts, aren't simply the unstructured data, although Facebook posts have a decent amount of metadata as well. Tweets actually have a lot of important information. Not only it has links to existing conversations, references to external links, user information, timestamps, and other information as well. So data still has structure. Keep that in mind. And the strategy is how do we integrate that unstructured data with traditionally structured data. Last point here is that NoSQL means no SQL, like bad. And actually, traditionally, that actually was the original NoSQL movement was really aggressively moving away from SQL. And now they've kind of backpedaled and said, oh, no, we meant not only SQL. That's what it basically stood for. And I'm going to cover this in more detail in a later slide. But basically, the point being that your strategy of NoSQL does not necessarily mean that we're going to throw the baby out with the bathwater, but it's the idea that, we kind of have the right tool for the right type of data that we have to. And really, again, it goes back to the point of how do we have a strategy around our structured and unstructured. Because really, in the future, what we need to do is figure out how these two different types of data structures are going to cohabitate and actually work together. And that's hopefully what some of this next slides will cover, some of the new emerging technology that will help us do that. three big technologies of note. There's so many buzzwords and so many different ideas of strategies for addressing these challenges, but really three kind of categories that we've seen kind of gain a lot of popularity. One is these analytical DBMSs. Is this NoSQL file and database systems, which I'm going to cover in the following slides, and then of course this idea of complex event processing, or really kind of stream analysis, and I'll speak to those in these upcoming slides here. Analytical DBMSs. So this is a whole bunch of different types of technology. Some of it's hardware, some of it's infrastructure, some of it's programmatic, and it's all these different kind of strategies that come about to enhance the power of analytical DBMSs. So it's basically taking transactional systems, traditionally transactional systems, and enabling, by using a multitude of different strategies, the ability of enhancing the analytic ability of these DBMSs. So one of them is this idea of in-memory analytical processing. So this has to do with hardware. So many of us, if you own an iPad, you've probably had the experience of basically turning on the iPad, and it's basically exactly where it was the last time you turned it off. On the laptop, where you need to turn on the computer, and the disk will start spinning, and the operating system will get loaded, and it'll take 15 or 20 minutes to come boot up. When you turn the iPad on, it simply is on, and it basically looks exactly like it was when you turned it off. Thank you for the compliment, by the way. So the memory analytical processing allows us to, of this solid state memory, like we're seeing, for example, in the iPad flash memory, and this has basically become cheaper and cheaper and cheaper to produce. And in being able to get this, in hands of more devices, and now seeing it kind of migrate over into, our servers, stacks, and things like that as well. And what we're seeing is memory takes up less and less space, but what traditionally used to be done in, this is a kind of a cliché at this point, but, we've heard that from the standpoint of backup, that tape, disk is the new tape, and memory is the new disk. So basically what we're talking about is that what used to traditionally be stored on tape as legacy data and then would be processed on a database, on a disk, a spinning disk, is now being pushed, that spinning disk processing is being pushed into memory, live memory, and then of course what traditionally would be on a tape is being moved into disk. So what you're seeing there is an evolution in the speed of processing. So the point being that just by using solid state memory, some of these new hardware offerings, you're basically taking everything and seeing a exponential growth of speed by the fact, simply by moving your hardware strategy from something that's disk to memory. So that's a key feature there, and that's something that's going to be impacting basically anybody. I mean, even if you simply migrate your database from a traditional system onto, something that's going to be running in memory, you're going to see a huge growth in performance, even if you do nothing else. So that in and of itself is going to show huge benefits in the upcoming era. Other things as well, parallel processing database engines. We see a lot of these hardware offerings where we're seeing processing baked into it. It's like a device that's being built to order and basically allowing us to do parallel processing within the device itself, tuned to this database engine. So we see this with a lot of data warehouse appliances that parallel processing is like a language and everything that's customized to the for this parallel processing offering. What we're seeing there is, once again, this is a lot of it is hardware. Some of it is, operating system specific too. But once again, a much faster way of processing data in parallel and using different data processing techniques. XML databases. So once again, the idea of taking data that is semi-structured, that we're carrying in the form of XML, and in some cases, better to store that within an XML database, which is formatted to capture that XML structure, better than traditional relational systems, which are not really great at capturing some of the requirements when you're building applications that have XML definitions. Especially those definitions can be very narrow but very long, and can have very odd structures. You can end up having a traditional database where each row is sparsely populated. So to that effect, the data structures are accommodating that by these XML databases. And of course, now we're seeing query languages specific to those XML databases. Another emerging technology, columnar databases. So this is actually yet another thing that's very popular for analytical engines and for data warehouses. Basically, a way to store your databases. This is kind of, I'm going to oversimplify it here to kind of make a point. But imagine that, in a transactional system, you're basically swiping your card, and the database is going to pull up your credit card or your account information, and then either make an addition or subtraction to that account based on what your transaction information is. And that's very good for that type of transactional system. And basically what you're doing in a transactional system is that we're taking, we're basically moving down the X and, the Y axis, I think I'm saying that correctly, to locate a particular record and then making an update, an insert, update, or delete of that specific field. So that's traditionally what we're looking at. However, in a data warehouse, that's not the type of transactions we're looking at. We're looking at all the sales for a particular day from a particular location. So in that regard, what we want to do is basically take all the sales information and put in one long column so that we can quickly do a summation, because we basically have these sections of like fields all lined up in columns. It's very easy to process on them. And that's where columnar databases come in. So you can imagine that from the point of view of your data warehouse, that structure is going to be much more convenient, much faster and easier to maintain, and to query against, to actually just build your queries, than it will be with a transactional system, where you can imagine that if you're looking for sales from a particular date, going through a transactional system looking for, out of millions of records for the 100,000s of appropriate records is going to be very time-consuming. And in addition to that, we're also seeing operating systems, applications, new programming languages, all different strategies that kind of deal with dynamic workload storage and compression management. So these are kind of very broad, different emerging strategies. But the idea is that now we have the hardware and we have the software in some of these event processing engines to allow us to do exactly this, where, for example, I can build my infrastructure on demand when capacity demands it. Does this server, I could have 3 server images running, basically in like a shadow mode, and then at the moment when a system is required, it comes online, all the pieces that are required to distribute from one application to another come online, and I can basically build that capacity on demand, and then it can go quiet once it's no longer needed. Similarly, I can have data that's very active, that is uncompressed, and then of course once the data quiets down, maybe at the end of the workday, we can have an automated compression of that data. More active records can be automatically allocated into solid state memory, and then of course when that data becomes legacy, maybe in the following day, it can be automatically pushed into onto a disk somewhere, and then the more recent data can be pushed into into live memory again. So we have the ability of, we have the hardware and software expertise now to actually take advantage of these features. NoSQL. In the past, the topic of NoSQL kind of, this is another term that gets thrown around a lot, and it's kind of hard to put your thought on what the definition is because it kind of evolves quickly. In the past, many of you may have heard of vSAM in the past. Traditionally, NoSQL simply meant non-relational transactional systems. So it's primarily what we were seeing, transactional systems that capture transactions but weren't necessarily as working as to enforce the relational data structures as we used to seeing from the context of an relationship diagram. So these kind of more open formatted non-relational systems, there were as many pros and cons to that type of architecture in the past, but now it's become maintaining a relational system for data that's constantly evolving and whose demands or actually definitions keep changing is often not something we can use with some of these, in the context of a lot of these big data challenges. So in the current times, NoSQL oftentimes becomes synonymous with the concept of a company or specific with technology, which is open source technology, by the way, of Hadoop. Hadoop, anybody who's curious about the name, by the way, it doesn't mean anything. The developer of Hadoop basically named it after his kid's stuffed elephant, and that's why their logo is the elephant. And so don't rack your brains about trying to figure out what Hadoop means. It doesn't mean anything at all. But so Hadoop is, has become like kind of the NoSQL engine of choice in recent times. And it actually has multiple components. Initially, it was simply the file management system and this MapReduce parallel computing engine. And I'll give you a little history on that. Internally, Google uses a concept of MapReduce to actually to index all of the data across the entire internet. Speaking of big data challenges, imagine Google's challenges. They basically need to index every single web page out there of the billions and billions of web pages out there and make it conveniently accessible via a search, which returns in milliseconds. So that's quite challenging. They need to deal there. So they wrote a technical document explaining how they had a strategy called MapReduce to handle this. And basically what the MapReduce allowed them to do was it went out, crawled the internet, and it would basically read the metadata for these files. It would read some of the content of these HTML files all over the world, and it would crawl it and basically go out and index these different files. And they would map, so that was the first part of it. It would map all this out across the entire globe. Then it would do a reduce. So as it's doing a reduce, it would start to, it's imagine like a diamond shape. So we have like the first upper part of the pyramid where we're mapping, and then on the bottom part we're reducing. So imagine that every web page gets a count of 1, and then as you to reduce, we should start increment counter. Let's say every single time that page is referenced by another page, during the reduce, we increment the counter. So basically, by the time we get to the bottom of that diamond, the inverted pyramid part of it, now get to the point where we have a particular page, we see data management as part of its indexing and been referenced by 700 other pages. And of course, that one's been referenced by 700 pages. It gets ranked number 1. The one that got referenced 400 times gets ranked at number 2, et cetera, and so forth. So they explained this kind of MapReduce technique without actually providing code or anything like that. And then what this guy did, whose name escapes me right now, I apologize, but you can look it up on Wikipedia, I'm sure, was that he basically developed technology that programmatically did exactly that. And then he made it available open source via Apache as this Hadoop engine. And then it allows distributed management system. So what it allows you to do is to do exactly what that MapReduce example that I gave before allows you to do. We can put it on 40, 50, 100 different servers, and it allows you to basically index the files that are out there. They could be documents, they could be log files, they could be anything that's kind of unstructured or semi-structured, and basically index it out on the operating system where it lives. And we simply create an index file that allows us to know where that data is, rather than actually capturing it like we traditionally would with a relational system. So we have an index that maps to the structures and where they live, and then some information about them as well. So then we could quickly locate them in the future when we need to. But not only that, if we're going to, for example, do some analytics where maybe there's a log file here, there's a log file there, but I'm looking for a specific IP address, once I don't collect all of my log files and then do the analytics, I basically send the job out to the remote file management system, or to the remote operating system, I should say. Let the operating system remotely do a very small calculation. It's not intensive, it's a very small calculation there, and then basically the result of the job gets sent back, and that's all that gets sent back. So I don't need as much storage. The storage is handled by the remote device, and I don't need as much processing power, because the processing power is going to be basically, we're going to create a job that's going to be handled by millions of systems at once, and then just the aggregate result of that calculation comes back. So in a very broad terms, what the Hadoop's file management system allows you to do. They also have a parallel computing engine. This is MapReduce, and of course that's exactly what this parallel processing allows you to do, is to basically take that job, break it up into parallel processes, and then aggregate them backwards. So we have that engine as well, beyond the file system. They've added to that analytical processing languages. One's called Pig, because guess what? Because his son's pig was called Pig, the stuffed pig. And we also now have, they also have database support via HBase, which is kind of allows SQL allow SQL to be queries to be generated against the data, although not traditionally against the data structure. So it's a little complex, but they do have database support as well against running queries against using this HBase structure. So Hadoop has really become almost synonymous with NoSQL, although there's many other vendors out there that have similar technology or who have taken Hadoop because it's open source, and then tweaked it significantly. And basically, whether you're looking at Google and you're looking at Facebook, you're looking at any of these different vendors, you basically are looking at different strategies that are very similar to the techniques described by that MapReduce functionality. Last of these is our complex event processing. So this is another key feature in handling big data is the idea of analyzing stream data. So you've probably heard of CEP and weren't really sure what that meant. This is another really big emerging buzzword, although it's been around for a very long time. But once again, like a lot of these other strategies, that hardware, technology, I should say like applications have come along, and just user experience and expertise has developed where we can actually fully take advantage of this complex event processing, and it's also necessitated by when you see some of the challenges that are occurring out there. And basically what it comes down to is how do you analyze a stream of data and find opportunities and threats. But now this is not traditionally the old school methodology of basically having someone fill out a form, the good experience, to have a bad experience, but basically analyzing a stream of data and identifying whether we have an opportunity here for an upsell opportunity, for example. Amazon uses this type of technology when they find additional products that they can offer you. And as a fact, they've seen a huge increase in their total number simply by offering, someone bought a Blu-ray player, you guys should also buy the HDMI cable. And rather than basically have someone sitting there and writing code saying, make sure to offer an HDMI cable whenever somebody buys a Blu-ray player, or make sure if anybody is going to go see The Dark Knight this weekend like I am, if someone buys The Dark Knight on a Blu-ray, make sure you offer them the Batman Begins on Blu-ray as well. The reason I mention that is because it's become a huge boon for Amazon's the business they do, but beyond doing beyond it as well, the fact that the technology under the covers is not that they are actually, like I mentioned before, it's not somebody programmatically saying remember to do this when this happens. It simply is evolving. So as the stream changes, as people users buy this product and that product, in real time, the complex event processing engine simply says, someone bought this product, I should also offer whatever products are now in this bucket of related products. And those products can evolve. Around Christmas time, you've probably experienced this when you buy from Amazon, that there'll be a particular special offer when you buy one product and another. And while that offer is live, you'll see that it becomes offered to you because that is a very popular offer, those two products together. As the discount ends, the next hourly deal comes up, that fades from the list of popular offers, and it just disappears from the offerings list. Once again, it's not somebody managing that. It's the companies listening to their data. And this is really something that I talk about, big data in general. It's really about, this is really kind of a fundamental shift, is listening to your data. And we now have the technology where we can do that. Oftentimes in the past, traditionally, your data management teams were kind of guessing at your corporate domain were guessing at what data they need to store. You now have the ability of seeing your data in real time, seeing what people are putting out on Facebook, somebody complaining about your service out on Facebook, and everybody's putting a Skype number to be reached at, or an alternate email address that doesn't match with your customer information on that user, telling you what data matters to them. If you listen to the data, if you find these patterns, you'll be ahead of the game. And threat detection as well. Actually, I'll go back to that slide. And threat detection as well. If we see this all the time now, where there's even instances where companies are doing kind of corporate espionage and corporate attacks against each other, and even nations have kind of had these wars where you've seen denial of service attacks on corporate websites, or I should say on government websites, one country versus another. And the point being that if we identify that threat, if we start seeing a subset of servers hitting requesting service from our a core serve hours, and we identify that immediately, we can basically shut those pipes off before we get our server gets overwhelmed and crashes, and then we can actually react to that. Finding out a month later that somebody, attacked our server, and that's the reason it went down. And it was basically these 6 servers that had some virus on them, or maybe even an internal virus. It doesn't have as value knowing it after the fact than knowing it in live time as the threat is encountered via the data that's coming through the data stream. Who to watch to kind of see these trends? Amazon, Apple, Facebook, and Google. Basically, these 4 companies are like frenemies right now. They're all work together, and they all are trying to destroy each other simultaneously. And it's kind of fascinating to watch because you see that Amazon, for example, is getting into the mobile device, and then I'll bring up the kind of background for these companies. So first of all, mobile devices. Google is an market leader for mobile devices with their Android devices. Apple, of course, first to market with the idea of the touchpad and the iPhone as well. But now obviously falling behind Google with market share. But the two of them are in obviously heated battle there. Amazon, of course, now introduced their own tablet, pushing services, allowing users to purchase through their Amazon devices. And Facebook. Facebook does not, and this is actually a big weakness in my opinion for Facebook, and I think it's why they're completely overvalued, but Facebook does not actually have any device. So basically these guys can shut them down at any time if they wanted to, not that they will, not in the near term anyway, but from the point of view of Facebook, that they basically are being accessed to a huge amount via these Apple and Google devices. When you think about the amount of features on Facebook, whether you're posting a picture via Instagram or you're being able to check into a store to get a coupon, or check into a restaurant to let your friends know you're in a neighborhood, that all those features would be impossible without the underlying device. Very, mutually beneficial relationship between Facebook and these devices, but Facebook obviously is completely dependent on the ability of these devices, having them as a platform. And speaking of platform, of course, the devices are platforms. The Facebook is a platform. Of course, Amazon is building its own platform as well. Location-based services, like I mentioned before, if we're going to push coupons to somebody, if we know where they are, the added value of being able to, push those value, the proposition of knowing where they are when it's a whole other layer to offering somebody a coupon. It's been proven time and time again that if someone has a coupon when they walk into the store, rather than receiving the coupon as they're checking out, that it's like a 3-to-1 hit on that product. So of course, if I check in at Macy's, and Macy's has an app where they actually know where you are inside the store, it's a pretty amazing device. But if you check in into Macy's, that as you're going through the store, they basically could say, hey, those jeans you bought last time, they're on sale, and a huge volume increase in their customer loyalty and purchasing due to that. To marketing, of course, all of these companies are basically aggregating or collecting as much personal information as they can about you, and they all know more about you than you do. They probably know, they'll know when you're going to have kids at this point before you do. So it'd be a surprise to you, but not to them. They'll already have coupons in the mail on the way to offer you, baby clothes. But this targeted marketing, all this analysis they're doing of your personal information, is obviously the forefront of new purchasing power in the future. Of course, the big battleground as well is search and social search. So we see Google is still the dominant force for search. Traditional search has Google like 80% of the internet at one point. It really was the gateway to the World Wide Web. And now you basically see 80% of the internet is via Facebook or via a mobile device. So of course, Google basically had to have a mobile device to capture that market, and Facebook, of course, captures a huge amount of that. And that's a real big battleground. Apple is behind in that front. Apple is catching up as far as social media goes, because Apple behind the scenes right now is secretly building a social media network via some of the new features they have in their phone. So they're kind of covertly building a social network. See how that goes when they launch it. Google does not have as much success. We'll see if Apple can do it by kind of doing it backdoor way that they're going to blow it out in the next year or so. See how that goes, but this is really the battleground. And if you look at these companies, what they're doing strategically is really cutting edge. Like they're going to be there first. Basically, we're all going to be following them in the future, to kind of catch up to them. But if you can stay on top of what they're doing, where they're finding trends, where they're identifying these, business opportunities, they know before any of us. So that's really where to look for that kind of the cutting I see heading into this presentation, I'm just getting into some of these challenges that we're encountering. I do want to definitely rush through the second half of this presentation to kind of talk about, rather than kind of telling you where the big data kind of value position for data management in the future, I'm going to tell you what Information Week, they actually did their annual poll, and these were the top 10 CIO priorities for the upcoming year. And these pretty much are pretty static. You're seeing them, you see the list of things moving up and down slightly, but I'm going to go from 10 to 1, and I'll talk about each one's challenges, and then quickly, because I know we're running out of time, quickly go through the how your data management team can assist in these issues. You'll see, by the way, how these the CIO concerns actually are all underlying under the covers, even though most people don't even recognize it, how they all really tie into big data in some way, or your data assets in general. So improving collaboration. So that's the number 10 spot on the CIO list. And why? Because global teams need to collaborate. Of course, the more global we get, the more collaborative tools we need. Of course, for our supply chain partners, you see that because we had like last year with supply chain disruptions due to the weather in Asia and the tsunami in Japan, and you see how in Thailand and Japan, those two big supply chain interruptions last year, and you see how this really has a global impact. So we need a method of having a transparent way of collaborating with our team members and with our suppliers and with our customers as well. Inefficient processes. This is a huge problem for the CIOs, of course. Inefficient processes is a huge problem for companies in general in current times. Innovation is lost. This is a really big deal. Oftentimes you'll have somebody who kind of toils away and finds a really great fix for a problem in one little corner of the company, but this innovation is completely lost to the rest of the company because there's no convenient way of communicating that code or that process to the rest of the team members. What hurdles for this? Employees often don't even use the tools that get purchased for them, so this becomes a real hurdle for actually pushing out some kind of collaborative tool. 9 is exploring cloud computing. How come? Why? Because 80% of software as a service 80% of companies already have some kind of software as a service implementation. The benefits of that: quick deployment, maintenance is easy, it's scalable, right? You can roll it out very quickly to many different places, and you save a lot on capital expenditure. And then 59% of companies right now are actually implementing infrastructure as a service as well. So that's another big in recent times, and we're seeing that a lot of virtualized systems, a lot of virtualized infrastructure as well, and tools that are actually kind of handling that, using capacity and demand requirements, and of course you're saving on capex once again. Security is a concern. Cloud primarily. A lot of companies obviously have a cloud strategy in place right now. The majority of companies are pushing their services into the clouds and creating a collaborative space and a shared environment for the companies. But we're looking at internal cloud deployments. This idea of pushing data into a public cloud is still a little tricky given security concerns. Consumerization of IT. So how do we conveniently, push this out to our end users, the work that we're doing, the IT work that we're doing? How come? Because consumers are becoming more technology savvy, and it's compelling for them to be, have buy-in to the IT as well. People are doing it anyway, via smartphones and tablets. People want to be able to have the data when they want or have the access to it as needed. Hurdles. Are there cultural issues with accepting outside technology as part of the corporate ecosystem? This is a big concern, of course. How do you bring in, smartphones and tablets into your, network ecosystem where, you might have issues about security and about usage of the products in general? Social media. Why is this a concern for CIOs? Because of this reality, especially for younger folks, that a lot of interactions are occurring on Facebook. A lot of marketing is being done via Facebook and Twitter. News basically begins on Twitter at this point, and then we could just hear it on the news at night if we even watch the news at night. But most of us have already heard it on Facebook and Twitter and Facebook before we even get there. There's a value in knowing that Facebook and Twitter gives you free market analysis. You want to have an idea of you do an advertisement, you release a new product, you want to see how customers feel about it. Just do a Twitter search, and you'll know very quickly the reaction that everybody's having to your company and to your whatever product or service you're offering. And the advertising platform, right? So rather than spending millions of dollars to run a commercial that nobody's going to see, you can basically spend hardly anything, a couple $1,000, do 15 different marketing campaigns, blanket Twitter and Facebook with them. The one that takes off is the one that takes off. You didn't spend anything on it. So it's just a cheap way of strategizing from or marketing yourself. It's like a brand new broadcasting channel. What are the hurdles to this? You have a strategy, and really everybody's still trying to figure out exactly what that strategy is going to be. Getting the right people for the job. There's a lot of high-profile IT. I should say IT is very high-profile internally. Obviously, everybody at some point is going to be reliant on them. And then marketing is the market is very competitive. You're seeing a lot of the hot jobs in recent times, I should say, have to do with data-specific challenges. There's still economic fears. There's still fear of a double-dip recession. You look at what's happening in Europe right now. We're afraid that that's going to spread into the U.S. And budgets remain tight. They got tight during the recession, and they remain tight even now. Prepping post-PC era, this is another big challenge, of course, is how do we take advantage of this post-PC era, and why? Because among younger users, we're already there, right? They already are accessing services via cloud services. They're already accessing their email, their Facebook. They're putting their photos up in the cloud. This is the way that business is going to be run in the future. And of course, virtualization has become, because of technology and because of hardware, virtualization has become more agile, become more, more robust, cheaper to deploy, and users' expertise around that has also grown. So, we're ready for this post-PC era challenges, making those processes from, hardware to virtual systems, for example, can still require some time. Seeing big data, all the market leaders are doing it. It's like, where this direction everything's going in. Hurdles are there. This requires a lot of outside-the-box thinking. Opportunities are endless, but we need to have a strategy and think about how we're going to take advantage of this opportunity that big data enables. But really, there's not many experts in the field, so it certainly is a challenge. And then managing so much data is obviously, the more data there is, the more difficult it is to manage it, I should say. Number 3, breaking out of the 80-20 spending trap. And of course, as we've all heard about this 80-20 split, but basically it's that 80% of the time is spent on maintaining legacy systems. So how can you be strategic when you basically can't be strategic 80% of the time? So growth is not possible without making that investment. It's a cultural issues again. It's the largest roadblock. Getting people to stop doing things that they're doing every single day and kind of reanalyze all their systems is a difficult proposition. T1 with your business, because it makes sense, right? You want to correlate the business with, and also seeing that this is becoming, all the market leaders across the board, depending who you're seeing, regardless of what market you look at, all market leaders basically are data-driven now, and that's, something that everybody wants to do is, align your business processes with your IT. Once again, cultural issues are a hurdle. A lot of times business users don't see the value of IT. They kind of see them as a separate entity, and even internally to IT, they see, they think only about the pipes and they don't think about the purpose. That's a problem. Too darn slow is the biggest complaint. Number one, this is almost always number one. Everybody complains about the fact that, your business wants to evolve more quickly, but IT is always a bottleneck, and, they don't get any money to improve their process, so it becomes this back and forth that never really kind of gives. The suggestion I have here is that, think about being more agile in your development processes, and small and agile beats big and slow, and agile beats everything. That's basically, something that's been said. The hurdles are that big and agile is very difficult. Small agile is easy to do. Big and low is usually the norm, unfortunately. Big and agile beats everything, but big and agile can be difficult, and it can be expensive if you're really going to tear out a lot of infrastructure and come in with a whole new strategy. Our data modelers, traditional data architects, and data modelers really help here. From the point of improving collaboration, modelers and architects are already users that hurdle, or I should say straddle, the business and IT world. This is really their job. They've been bridging these teams as part of their job description from the very beginning. Really take advantage of that asset. If you internally are a data management expert, make sure to promote your own value internally. And if you're a business user who's listening to this right now, remember that your data management team, really a lot of what you're looking for as far as building a big data or just a data strategy in general, a lot of that expertise is inside of these data management teams, your data architects, your data as well. Moving to the cloud, once again, big about security. but remember that if we actually understand the underlying data structures we're looking at, your data management teams often have a very good idea as to what data is safe to put in the cloud and what is not. If you want to go into a public cloud, maybe the Facebook posts and Twitter feed that you're collecting for your users, this unstructured data, is very safe to put in the cloud because it's basically public information anyway. But of course, maybe their credit card information is something that should be locked down, and we've seen issues where a lot of that data was not very well secured, even internally. So it's something to think about, and those data management teams have the metadata as to what is safe and unsafe to actually move into a public space. Integrate that internal and syndicated data. Once again, someone who's spent their career kind of identifying or defining entities, enterprise-level entities, kind of has a very good understanding if they know where the customer data is and they know what is core to a customer definition from a master data level or even just from an enterprise level. They're really a great resource for that integration and also syndication of that data as well. Social media. So I have an example here. Here's an email that I wrote, and I put it in my iPhone, and I kind of make a point here. Even within your structured data, there's traditional data, and that traditional data still is going to end up in a transactional system somewhere. So in this email, basically said the DAMA events on Wednesday, this is the location for it, and these are the phone number you can reach me at. And you see that, and everybody who has an iPhone or an Android has seen this, where you basically see that you have these, contacts becomes active, and basically if you click on it, it'll open a map device, or it will allow you to add the contact information to an existing contact, or it will allow you to open a calendar. So the point being that these are applications. They have their own data structures. With some kind of semantic analysis, unstructured data is not as unstructured as you may think. It contains structured data, and structured data still needs to land inside of a transactional system. At least for the time being, that still is going to be the norm. I can't imagine it really going that much because that's such a mature process currently, and I don't really imagine it changing that much in the near future. People for the right, like I mentioned before, a lot of these hot jobs, a lot of these jobs that need to be fulfilled are around data and application integration. So remember, you internally are a huge asset to your company. Remember that, and look for those, that emerging trends in, make sure to promote your own value internally to your IT, your CIO, I should say. For the post-PC era, so, a lot of this post-PC cloud implementation really requires this idea of, a lot of this revolves around service-oriented architecture. And there's a popular article from Gartner that reads, SOA is DOA when there's no MDM. And basically what it acknowledges is that, if you don't actually do your diligence and get a handle on the data, your entity definitions themselves, then your SOA implementation is going to fail. So point being that you can't have this agile application-driven world without underlying fundamentals of data integrity. Harnessing data, once again, there's really a big data expert out there. Who is going to be the candidate, the person who's going to be able to identify data assets, analyze them for quality? Where else are you going to turn? Your data management team, your data architects, data modelers have expertise in this field as well. Break 80-20 split, identifying, follow the data is a key point. A lot of times your systems are, redundant, underused, out of date, or completely, or can just simply the capacity on them, the demands of capacity can be reduced on them, or they can be migrated to a smaller system. And basically, by following the data, by listening to your data, you can identify these assets. And data analysis reveals, any kind of issues that might be there, or identify these assets that can actually be scaled back. And data analysis actually reveals alignment. So that's another key feature. There's a big buzzword around business process management, but remember, data management and business process management are really almost one of the same. If you want to understand what's process, who's involved, who's going to govern this process, etc., listen to the data. Watch the data as it flows through the process, and then you basically will identify the process via those pathways and identify what systems are required, what human resources you need as well to manage them. Making with the business, like I mentioned before, business process management is really correlated to your data assets, so make sure to listen to your data. Project managers don't always recognize this. Make sure to promote internally. Let them know that this is a key consideration when they're defining their processes. It's job educate them, but make sure to make their job easier. That's another key point. Don't become another bottleneck. Make sure to make your job easier to basically say, oh, you're trying to build this process, you're trying to define these processes, you're trying to build these enterprise-level entities, for example. I have that expertise. Let me help you. Don't become a hurdle in the process, but really show them the value of participating with them. Consideration of IT, the data available to the entire corporation, and different strategies for that. Anybody who's seen the new Irwin web portal, very easy way of promoting your data assets to your end users. If you're curious about that, let me know, and we can show you some of that. And these too darn slow. Rather than going into this in great detail, there's a great article on Irwin.com. Tom Howey wrote this article back in October of 2010. And it's saying that what is agile development, and really talking about how agile development, even from an application point of view, and the data modeler really correlate, the value that data modeling, gives to your application development team. So I'm going to wrap up now, finally, and quick suggestions to data modeling professionals. So first of all, find where the business sees value, even if you disagree, and then start there. So if you're trying to get buy-in for a new initiative trying to roll out, find where the business actually feels a need, find out from them exactly what they see as an immediate challenge, and where they see that there's going to be return on investment, and even if you disagree with it, but then start there. If you can get buy-in there, you can then scale it out to an enterprise-wide solution. Promote yourself. This is, I think, IT professionals often have this problem. It's not egomaniacal to go out and tell everybody, this is the work I've done, look at how good I am at what I do. Not only is it not egomaniacal, it's actually required. If you do not it's social media world. People are constantly updating their LinkedIn profiles, etc. If you don't actually keep showing your value, no one's going to know you're there. It's very cluttered and an easy world out there. You need to speak up or you won't be heard. The world has ADD, deliver accordingly. So, think about how, everybody's attention span is, and make sure to make deliverables that fit into that, that time frame. If you deliver on time in small increments, you will get traction. If you have a really long 6-8 month window and you don't deliver, you won't get buy-in in the future. And then ingrained process and culture is the number one hurdle of progress. This always happens to be the case, that every single time that something new comes along that you simply can't get it rolled out because everybody's kind of stuck in an old process. So remember, even with your day-to-day processes, look at everything you do with fresh eyes. Try to do that on a pretty regular basis. You'll probably find that there's a whole process that can be cut out. Maybe part of your part of the process is maintaining a system that's no longer even online. You'd up a spreadsheet somewhere, even though the data is completely redundantly being stored somewhere else. So look at everything you do with fresh eyes and try to clean up your process as much as possible, and you'll reap large benefits from that. The big dummy is here. With the data management strategies in place, this is you can have a strategic advantage over your competitors. So you can basically, take this, leverage it as, kind of ahead of the curve with this. Big data challenges are only an impediment if you fail to plan. Otherwise, you can actually take advantage of them and see them as a corporate asset. Be afraid to fail. If you fail, make it quick and cheap, and learn from your mistakes. A long-term, long time that leads to a 6-8 month project that eventually fails or is basically shut down is a huge failure. If you have a small failure, test something out, send out a trial balloon, and it fails, you learn something from that, and you could quickly evolve and then have a success built upon that. But remember that, keep that in mind. We have the opportunities now and the an expertise to kind of have many small failures to lead to a large success. So bear that in mind whenever you plan out your projects as well. So you can reach me at victor.rodriguez@techextend.com. If you want to reach me on LinkedIn, we have a Maximum Data Modeling group, just Maximum Data Modeling. If you do a group search for me on Twitter with Max Data Modeling, and my blog as well. And with that, I think we're going to take some questions if there are any. overtime, so many of you had to drop off. And we also do not appear to have any questions, I don't believe. So thank you for your patience, and thank you for attending. And we'll see you at the next webinar.